in the X-ray failure analysis business, engineer brings us a board. Let's say it's a server board of some sort, has a large FPGA on it in a BGA package, 2,000 pin BGA. He thinks, based on time and experience, that his failure, his opens that he's experiencing are at that location. Asks us to X-ray that location. We spend several days on it, sometimes frustrating days, because we agree with him when he comes in. It's got to be there. It's the largest, most dense component on the board. We don't find anything. All of the joints look good. They meet IPC specs. We don't even see anything of a marginal nature. And then, usually for good measure, we'll have our technicians do a scan around the rest of the board, around the periphery. Not a lot of time, but just a sanity check. And more often than not, we'll find a problem somewhere else. We'll find it on a connector. We'll find it on a less dense device. We'll find a dead short somewhere. We'll find a lifted LAN somewhere. We'll find a void that's about to break into a crack. And we'll have to go back to the customer and say, the good news is your joint is clean where you suspected it was, but the bad news is we found something else, at the opposite end of the board. Very common occurrence.
That's my guest, Robert Boguski, next on Reliability Matters.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Robert has worked in the electronics packaging and interconnect manufacturing and testing business, primarily in management positions, since he was a teenager in 1975. 22 years in the bare board business, 12 years in the EMS industry, and 14 years in the testing and test engineering business, some of which overlapped with EMS services. Together with his wife, Regina, Robert is the owner and president of Datest, a test engineering and failure analysis company located in Fremont, California. Robert and/or his company, Datest, are members of SMTA, IPC, and IEEE. Datest is also a member of the American Society of Non-Destructive Testing, ASNT, as well as the European Institute of Printed Circuits, EIPC. Since 2013, Robert has co-authored the Test and Measurement column for Circuits Assembly magazine. Robert is also currently the president of the Silicon Valley chapter of SMTA. He was also recently elected to the National Board of Directors of SMTA. Welcome, Robert. Thanks for joining me today on the podcast.
Thanks for having me.
So you and I have run into each other at various shows and local and international SMTA events. Tell me a little bit about yourself. You're the founder and president of Datest. We'll get into what Datest is and does. What was Robert's life like before the days of Datest? What brought you to that?
Well, I'm a second generation practitioner of electronic interconnection technology. My father started working in the printed circuit board industry in 1956, I believe, working for a company in Glen Cove, New York called Photo Circuits, which was one of the original merchant printed circuit board fabricators in this country, at least. And he worked in that business his entire life for various companies. And I inherited the board chromosome, I guess you could put it. And I started working in the business when I was a teenager back in high school. My father started his own company called Apogee Engineering in San Jose, California. And I worked there in my off hours from high school. I would go to school by day and come in and operate an old single spindle bottom drill by night, working till midnight, drilling holes in boards with film templates on top of them. And it was very heartbreaking at midnight on the 2,997th hole to place that hole in the wrong location, because that would mean I'd have to start all over again. So there were some long nights in those days, but they taught humility and discipline and follow through, and I learned a trade at a very early age that has always been marketable, and I've kind of branched off from there into various other sub areas of the industry having to do with design and assembly and manufacturing engineering, and most recently where I find myself now in the test engineering business and failure analysis, where I've been now for the larger part of the last 14 years.
That's very interesting. You're the third guest that I've had. The two others were from board fabrication shops that took over from their fathers. They were given all the, in fact, your story of having to drill holes was exactly the same as two other guests. I guess when you're the kid of the owner and maybe you're not of legal age to work or they don't actually have to pay you, a little bit like farm labor. They send you out into the fields. In this case, the fields were drilling holes in boards. And you're the third person that has that experience starting off.
Not only was I the farm labor, I was the slave labor for the first year, 18 months of the company.
Right.
Now that my father is dead and buried and gone, and that company is long gone, I can safely say for those first 18 months, I worked for nothing. Basically, I put my hours on a time card in the hopes that at a certain point, cash flow would reach a point that they could pay us. And fortunately, it did, and I was. But you learn a lot from that experience.
Well, certainly. I used to work with my father when he started a business, and not in this industry at all, but it certainly teaches you business and humility and all the things you didn't really sign up to learn, but there are things that certainly land on you. So, before we start talking about testing, and there's a lot of subject matter with testing, I have read several of your articles. You actually are, I think, a co-author of a test and measurement column in Circuits Assembly magazine. Is that right?
That's correct.
Okay. So I'm going through the archives, and you are a very interesting writer, and we won't have time to get into everything, but there's one particular article you wrote where you just posted a lot of questions. I could imagine maybe it was a tough day at work, and you just came back and just started, ranting or whatever. But they were all great questions, and some of them that just came to the top were, why do we still worship youth? Haven't we learned? There's probably a story behind that question. And then you wrote, what you meant by that. Why is Silicon Valley overrun by assholes? I would love at some point, maybe not today, but at some point, in a bar over a drink, figure out where that sentiment came from. I imagine it's through some type of experience. And I'm a big fan of the show Silicon Valley, the cable show Silicon Valley. And just based on watching that show, which I understand is fiction, probably fiction based on fact, I could totally get where that sentiment came from just based on that show. One of the other questions you posed was, what were we thinking when we allowed manufacturing to go to China? I think that is a question worth asking again today, because today that question has shown itself very loud with everything that's going on today with the stock market. People will listen to this several weeks from now, so I would imagine the stock market will have recovered by then. But today we're down about 800 points, and a lot of it is the fear of the trade wars in China and all this, China threatening us with rare earth materials and all this kind of stuff. People not getting stuff out of China because everything that's going on with Hong Kong, and it's just, it begs the question, we went there, why? Not that there's anything wrong with China, but the way we did it, we kind of just threw everything in. That was
Tim Cook's job at Apple. Steve Jobs hired him to streamline their manufacturing process, and Cook led the charge to offshore all of Apple's manufacturing primarily to China, which makes it ironic in the last couple of years with Trump conducting his tariff wars with China. Among the loudest voices opposing the tariffs was the management of Apple. And whatever one may think about Trump and his politics, there is some favorable sentiment about standing up to China. And I know I was reading an article not too long ago in The Economist magazine, which said that Cook violated one of the fundamental rules of supply chain management, which is to always have two sources of supply. He established a single source of supply, thereby having built-in vulnerabilities in the event of something bad happening. And something bad is quite obviously happening now. And Apple has gone running back to the administration on more than one occasion saying, help us, or give us some relief from these tariffs. And Trump, his rejoinder has been, well, if you were manufacturing in America, you wouldn't have the problem with the tariffs, would you? And separate from one's political persuasion, I have to tell you, a lot of people heard that and said, right on. You know, they got exactly what they deserved. There was a lot of schadenfreude expressed for Apple, and that kind of feeds into the comment you mentioned earlier in my article where I said why are there so many unsavory people in Silicon Valley, to put it diplomatically. That cascades down from jobs. We have a whole host of people who have tried to be Jobs' mini-me in the years since he died, with the same attitude, the same uncaring about people around them, the same lack of feeling for where the jobs are going to be and where the support's going to be for the industry overall. It's just go to where the last lowest wage is, where the last lowest unit price is, without thinking of the long-term ramifications of that decision. And we're now living out the after effects of those decisions right now.
Yeah, I've said this on the podcast before, but we're one of the few industries where our customers' products are expected to be half the size, half the price, last twice as long, year over year over year over year. It is a diminishing returns, and in many cases, it's a race to the bottom. And at some point, we as a collective society, not to get philosophical on us here, but we as a collective society need to understand or appreciate what value is. And value is not always the lowest price. In fact, it rarely is the lowest price. Value is the best return for the investment, for the energy extended. And that is rarely the lowest price. And, if consumers would, actually be agreeable to pay for value received as opposed to some artificially low price, then we could have more manufacturing in this country. And so could China, and so could Europe, and so could Mexico. And it wouldn't have to be mutually exclusive. We could definitely have some value-added manufacturing and valuable manufacturing in this country.
I agree.
Another thing you said, which I love, is how did we ever manage to convince ourselves that 140 characters or friending represents innovative activity? I think I've listened to several talking heads that I enjoy listening to, and some TED Talks on that subject of how the younger generation, I don't want to use the word millennials because I'm not one of those that just blames every younger generation. My parents blamed my generation, and we blame now the younger generation. It's kind of a rite of passage, I suppose. But we certainly have a society that has a difficult time communicating because their world is text messages and emojis and things like that. And we see that when we hire people. We're a manufacturer. We hire people of all different ages and backgrounds, and I've definitely seen a trend with a lack of communication skills coming out of certain demographics and I understand why. They were raised on conversing in a very minimalistic, less personalized way, and that shows itself in the workplace.
They were trained not to express thoughts longhand. And I don't necessarily mean by that you need to write everything down on legal paper, but you start with a premise and you reach a conclusion. So much of what is said by certain demographic groups nowadays is expressions of sentiment or bias or prejudice, or the last thing they saw on their screen, or the last tweet that they got, and it doesn't represent true thought. Starting with a problem, wrestling with it, grappling with the implications of it and reaching some sort of a conclusion. And this is really highlighted recently. We've just been through the 50th anniversary of the Apollo 11 landing. And if you've watched any of the documentaries that have been on about that, or some of the literature, the printed literature, it talks about that extensively, how in the space of really 8 years, a whole program was built from scratch, where we were behind the Russians in 1961, and 8 years later, we had the first man on the moon, and an entire industry developed out of that. And a lot of the technologies that were developed in the space program, we use to this day, especially when it comes to computer technologies, microchip, some of the coding techniques that were used, some of the hardware that was used, was adopted worldwide in many different industries. And it makes you wonder, do we have that capability today? If given that challenge today to undertake a similar problem, could we rise to the challenge? Could we as a country, or even as a world, rise to that challenge? I'm not so sure.
Yeah, and in today's highly competitive, almost exclusive environment, there's much less mutual cooperation. I mean, a lot of people don't realize that the space program was supported by hundreds, if not thousands, of companies. Playtex, the Brog-Girdle company, made the spacesuits, and you didn't see Playtex labeling all over it. You didn't see, sponsorships all over it. I think you saw NASA, and that was about it. Everyone gathered together for a common goal, and their recognition, by today's standards anyway, their recognition was largely low key compared to today. If I look at a race driver today, you can barely see what color suit he has on because it's covered in endorsements. His car or her car are covered in endorsements. And the space program was, the people within it knew who the players were, but the general public just knew this was the United States trying to put a man on the moon. This was not a race this was not Playtex. This was not Lockheed or whoever, the
Sure.
major high-tech players were at the time. This was just a country effort, and everyone chipped in. It was something that I don't know if we would ever see again now that space has been privatized. And the interesting thing about that is it's very uncommon that technology stops or goes backwards. Technology usually, once the Pandora's box is open, once the bottle is open, the genie gets out, and technology just grows exponentially. But in the case of the space program, I mean, we have become, and I don't want to say the word complacent, because putting a man on a spaceship, circling around the globe, 20 times and then landing them safely is certainly an accomplishment, even by today's standards. But, we haven't been back to the moon since, whatever the last Apollo mission was. We haven't been there in
72, I think.
72. And, we used to fly commercial aircraft at supersonic speeds. I was fortunate enough to fly Concorde before they grounded it. And, unless you join the Navy, you're not going to fly. You and I aren't going to fly again at supersonic speeds. It's very unusual that technology goes backwards. But in the case of the space program, it certainly did.
Well,
manned space flight, anyway.
That's why I made the 140 character comment. I'm old school in the sense that I feel that a society, a country, derives its self-worth from its ability to make things, tangible things. A Boeing 777 is a tangible thing. A computer is a tangible thing. A defibrillator for life support, life-saving purposes is a tangible thing. An emoji is not. And unfortunately, the workforce of the future, where I live at least, is gravitating toward the companies that are the emoji makers of the world. Slight exaggeration, but not by much. I mean, they want to leave the elite engineering schools and design apps, because you can design an app, market it, and if you're lucky, at the right time, you can make a killing and retire at the age of 28 and then go do what you really want to do and tell the rest of the world how to live through your charitable donations on the basis of one lucky break that qualifies you to pontificate on everything else. And I just don't follow the logic. But again, I'm old school, so perhaps I'm a dinosaur when it comes to those things.
Well, we probably won't be around to know if we're right or wrong. Although we have to be kind to the younger generation, because they'll be the ones largely taking care of us when we're not able to take care of ourselves. So we have to have hope, right? We have to have some degree of hope.
Well, and I keep trying to hire them, and there are many good students out there for what we look for. We're not looking for app designers in the failure analysis business. We're looking for a unique student, and they do exist. We know by experience they exist. And it's a hard search for us. For every 20 that we interview, we find one diamond in the rough. But yes, they are out there. You just have to be prepared to make the effort to find them.
Sure. And I think that could be said at any time where the economy is strong and the unemployment rate is low. I think our U.S. unemployment rate is around 3 or 4%. And, I'm kind of a believer that about 5% of the population has no interest in working for great reasons or not so great reasons. So when we're at 3.5 or 4% unemployment, we're really at a minus, negative number of employment. So we're basically at zero unemployment. So someone has to want to work with you. Very few people are in the situation where they spent 6 months looking for a job and will accept anything. It really is an employee market as opposed to an employer market right now. At least that's what we see in Southern California. You're in Northern California, in the heart of Silicon Valley, I believe. So things may be better or worse up there. But certainly, when the employment rate is so high, when the unemployment rate is so low, it becomes challenging to find people actively looking. It happens, but it's certainly more challenging. Let's talk about testing. Your company is for lack of a better description, a contract testing house. Is that right?
Yes.
What types of, and it's mostly on circuit assemblies, right? You're testing electrical circuits or boards, bare boards perhaps. Tell me what types of tests you perform and what those tests are designed to test for. So what problems would I have to solicit your services for specific tests?
Well, our main mission in life is test engineering, which involves the development of hardware and software for testing assembled printed circuit boards as opposed to bare printed circuit boards. The bare board fab houses have their own test departments doing what they do, testing for shorts and opens. We get the board after they're done and after the components get loaded on the board. So we take the design documents pertaining to a particular board and we adapt a test solution most appropriate to that design that will check that every component that has been specified to be loaded on that board is in the proper position. It's not installed backwards or missing or upended or tombstoned. It has the correct value. So, a 10K resistor is not a 1K resistor and so forth. Nothing is, if it's a polarized component, nothing is installed the opposite of the polarized direction. The digital ICs are correct as specified, and all components meet the tolerances that the customer's bill of materials and schematics say they're supposed to do. The short answer is we do a workmanship check. We take that board, it comes right off the line, and we use the methodologies that we have to ensure it was built as specified. What we do not do is pronounce judgment on its fitness for purpose as designed, and that's an important distinction. That's a different level and set of parameters for testing. We're simply ensuring that everything that's supposed to be there is there, that it matches what the docs say it should be, and that there's no extraneous workmanship defects. So no solder bridging, no foreign material, no organic material left on the board, flux residues that aren't supposed to be there. no opens, no shorts, that there's solder in through holes where there's supposed to be solder in through holes, and so forth. And for that, we use a variety of methodologies. The most commonly known is called in-circuit testing, where we design a rigid test fixture that serves as an interface between a grid on a test machine and the board. The fixture, call it an adapter, if you will. We take the customer's CAD, and from that, we're able to design a bed of nails fixture that mates to the board. And when you pull a vacuum and apply pressure, a ram comes down and pushes the board against the test probes, and you can then inject signals into the board that perform these various tests that tell you, hey, this was built correctly. We also use what's called flying probe testing. Similar end result, slightly different methodology in that the board is held in place and then probes move in X, Y, and Z directions, making contact with the board and again injecting signals. This method is more suitable for low volume manufacturing and prototype NPI manufacturing. And then beyond that, we do what's called JTAG or boundary scan testing, where we run signals to certain designated points on certain digital devices on the board that are chained together and may not have physical probing access, but if they have certain key access points end to end on the board, we can ascertain A, whether they're on the board, B, whether they're talking to one another, and C, whether we can program them, load code on them, load certain infrastructure functions on FPGAs and so forth. The last methodology we have is something called automatic X-ray inspection, which is, as the name implies, a robotic inspection test which looks at solder joints. We take customer CAD, make a program, and then load that into the machine, which inspects top, bottom, left, right, and center. And if the board has 10,000 joints on it, it looks at all 10,000 joints, and any defects that are in violation of IPC specifications, it flags them and takes a picture of the defect, and a skilled operator can then review that data.
I think the operative term is skilled operator. I look at these X-ray images of boards and other types of AOI type things, and it reminds me of like an MRI or a CAT scan in the medical world, where I look at it and I see some abstract image, but it takes a skilled technician to look at those images and know what they're looking at. I assume if everyone was given tomorrow an X-ray machine, automated X-ray machine or similar type of inspection device, that alone, access to the technology alone, is not enough to provide accurate discernment that a board is built properly or whatever you're looking for is or isn't there. It takes a lot of skill. Is that correct? Is that?
Yes.
Yeah.
You know, first and foremost, you need to know what you're looking at, which requires skill, and skill is acquired over time.
Yeah.
Most of our operators have 10 or more years of experience looking at images like this. Think of us when we're doing automatic X-ray inspection, for example. It's analogous to the radiologist. You go and have a chest X-ray, and they put a plate up against you. You're exposed. There's some form of lead shielding, so you're not personally exposed to the X-ray. And then there's a bunch of clicking and whirring, so something's going on. And then they tell you you're done and you're dismissed. And then you hear from your doctor typically several days later with the results of the X-ray, and hopefully it's good. But you never see the radiologist. Well, we're the radiologists. So we're the persons looking at those images and interpreting what we see on the picture for the customer. And just like the radiologist in a medical application, you know they exist because at a certain point you get a very large bill. Well, that happens with us too, because we have that skill. So we're going to bill for our time, and that's what the customer's paying for. The expertise to identify, in many cases, very minute defects, which could lead to a catastrophic failure.
So do you ever have a customer? I love to talk about things that don't go right because we can compare and contrast them to things that do go right. Do you ever have a customer that already that sends something to you? They have a problem, They send something to you, and someone there believes they know what the problem is. They don't have a way to test it. And we get that. We'll have someone call us up and say, our machine's not working. We think it's widget A. And we're like, okay, well, that's a possibility. It's probably more likely widget B, and there could be widget C and widget D. Can we test those first? Oh, yeah, those are fine. I already looked at them. And then ultimately, we find out when we send somebody out at a very large expense that it was not, they never did the testing. They already had this preconceived notion that it was widget A. So everything was tuned out. Everything was filtered out in terms of alternate potential causes for the failure. Do you ever have that in your world where someone says, yeah, here's the board. We want this test because we think this is wrong. And maybe that is or isn't the most appropriate test for that particular failure event.
Oh, Mike, we never have that. That must be unique to your industry.
there's the snarky Robert that I know. Good. Yeah, I think in your business that would happen on a fairly regular basis, right?
Give you a very common example. In the X-ray failure analysis business, engineer brings us a board. Let's say it's a server board of some sort, has a large FPGA on it in a BGA package, 2,000 pin BGA. He thinks, based on time and experience, that his failure, his opens that he's experiencing are at that location. Asks us to X-ray that location. We spend several days on it, sometimes frustrating days because we agree with him when he comes in. It's got to be there. It's the largest, most dense component on the board. We don't find anything. All of the joints look good. They meet IPC specs. We don't even see anything of a marginal nature. And then usually for good measure, we'll have our technicians do a scan around the rest of the board, around the periphery. Not a lot of time, but just a sanity check. And more often than not, we'll find a problem somewhere else. We'll find it on a connector. We'll find it on a less dense device. We'll find a dead short somewhere. We'll find a lifted land somewhere. We'll find a void that's about to break into a crack. And we'll have to go back to the customer and say, the good news is your joint is clean where you suspected it was, but the bad news is we found something else, at the opposite end of the board. Very common occurrence.
Yeah, that it's always frustrating. You want to listen to the customer because they provide the input, but sometimes Occam's razor fails you, right? Sometimes it's not the most obvious and the most simple explanation. Sometimes,
well, you mentioned preconceived notions. We've had a few episodes where process engineers have come in and they knew from the get-go what was wrong, which of course begs the question, well, fine, then why are you here if you know that? But they had us do the work anyway, and we came up with a defect somewhere, and it was totally the opposite of what the guy or the gal predicted, and it's usually begins with this preference. I have, insert years, this many years of experience doing failure analysis on printed circuit boards, and I know when, insert description of symptoms, manifest themselves. It usually means, insert description of root cause. And we have to say, well, fine, but based on our experience, this is what the pictures tell us. We find a head and pillow defect here, not there. The pictures are the evidence. You do with them what you will, but we're done. And here's the bill. That does happen, where we don't fit an agenda. We were really asked to fit an agenda, and unfortunately, our testimony didn't stand up in pretrial hearings, and so they had to go and get more testimony. It happens.
Yeah, sometimes you're an inconvenient truth.
Precisely.
And so when we spoke the other day in preparation for this interview, you brought up something that was very interesting, ethics in testing. Tell me what you meant by that and how that lands in your company and just in the testing world in general.
ethics to us means telling the truth when nobody's watching. In fact, we have that posted on the wall all over our office. It's not just a nice sentiment to us. It's a requirement. Our particular company is certified to the AS 9100 standard, and the current revision D, which has been in effect now for a couple of years, has an ethics component to it. So you must profess and give evidence to an auditor that you are abiding by ethical actions and demonstrating ethical behavior in the way you conduct your business. So for us, that means telling the truth. And occasionally it can mean telling inconvenient truths to customers who would rather not hear it, like your board is failing for the following reasons, and your assembly operation is not up to snuff, and we have the evidence to prove it. Or, like I just said, your defect is on this end of the board rather than the end you suspected. Or another good example could be somebody is in a great big hurry to get something done, and just by the nature of the project, it takes longer than that customer wants to get done. I've had people come to me and literally demand, in a very imperious manner, you will, of course, work all weekend to get this done. And they're telling me this at 4:45 on a Friday afternoon because they have to report to their management at 8 a.m. Monday. And it's just implicit that we will do everything we have to do over the weekend to get it done, regardless of the time expended or the personal schedules disrupted. And sometimes we have to say no. And often it's better to say no sooner rather than later and get the word out to the customer, the truth of what we can do, the truth of what capabilities we have and what they'll get for their money, rather than later, because later usually leads to recrimination. So we try to be honest, that could be also telling a customer who wants to do an in-circuit test fixture for a particular board, hey, we'd gladly take your money. It's a very expensive fixture. If we do it, it's going to cost you $50,000. But really, for a fraction of that amount, we can do it on flying probe and supplement it with automatic X-ray inspection for 1/10 of the cost that you'd pay for ICT. And you're going to like the results. We're going to get them to you faster, and you're going to save a lot of money. And you'll probably remember that. We're not going to tell them that, but implicit in the statement, it's the seed is planted, and hopefully you'll come back and work with us on other projects. So
one of the things you said, which really is driven home for me personally, is sometimes you have to say no. I've had my company, Aqueous Technologies. I've had that for 20, I think, going on 28 years now. And as a young 31-year-old starting the company 28 years ago, yes was the only word I knew. If a customer said yes, I'm selling it. Even if we didn't make it, we'll figure out a way. Just keep saying yes to everything, because that's what it takes. It's like starting an old car with starter fluid. It's like, hundreds of octane points, and you could never run a car on it, but you can certainly start it on it. And so saying yes to everything was starter fluid. But then over the years, no becomes a very mature word. No, saying no in many cases has made us more money, or at least saved us more money, than saying yes. And I've learned the hard way over almost 3 decades doing this, that the word no can be and often is more profitable than the word yes. And you do what you do. You can't be everything to everybody. And sometimes customers are disappointed, but that's just, someone will do it. It just can't be us. That's just not our cup of tea. And I've learned that even if you only do one thing, do that one thing really well. And there's no sense being an also ran, because there's just a race to the bottom in that case. So
I'll give you a concrete example from the world of failure analysis. A couple of years ago, a customer called me up and said, I've got 46 boards that I'd like you to x-ray. They're suspect boards. I think all of the BGAs on the board are bad. I need a report of the results. Okay, fine. 46 boards. How many BGAs on each board? 32. And I need you to CT scan each and every one of them. Well, that's not an inconsiderable task. And I did the math on what it would take hour-wise to do that job. And I came up with something like 120 man-hours to do that. And we bill by the hour for X-ray and CT scanning services. So having done the math, I went back to the customer and said, this is what you are asking us to do, and this is what it will cost. And at the end of that, we're going to hand you a 5-figure bill, which is great for us. It's going to pay for our company Christmas party this year. So hooray for us. But the chances are that you're going to be very unhappy with our service because maybe, just maybe, we're going to come up with inconclusive results. We're not going to find the smoking guns on your board. And all you'll be left with is a drained bank account. Let's rethink this. Instead of 46 boards, let's start with a smaller sample size. Let's pull 2 at random from the lot, and let's pick certain devices on the board. Rather than 32 BGAs, let's look at 4 or 6 or 8. And we'll do those in a few days and charge you a fixed rate to do them and see what we see at the end. And we'll have a couple of hundred images to share with you. So you'll have a lot of data to look at. And let's see what that data tells us. And, you'll be out a couple grand by the end of that. Fine. But let's see if it's meaningful. And if it is, we can then draw some conclusions from that. One of which is maybe they're so bad, that speaks for the whole lot. And that's as far as you need to go. If they're somewhere between really good and in the middle, we'll draw other conclusions and determine whether we want to inspect additional boards in the lot or not. But let's start small and see what it shows us and see where we can get from that and see how valuable that information is. And then we can assess the rest of the lot. And, I won't bust your budget and you'll be happy. And hopefully we can get where we need to go just as easily for a lot less money. And that approach historically has worked pretty well for us, guiding the customer along, educating them a little bit, making the terminology clear so they're not confused, and just explaining to them what we're doing, not hiding anything. Transparency. We find, that works too. That's an ethical way of doing business, in my opinion.
Yeah, that makes perfect sense. One of the questions you posed in one of your columns, before I have you answer it, I'll give an example. The question was, why are suppliers so afraid of their customers? And I think anyone who's listening to this that is a contract manufacturer or even an OEM can relate to that. I was at a contract manufacturer in California, and I was looking at this was many years ago, and I was looking at their cleaning systems that we provided and looking through the SPC logs, statistical process control logs, so I could see if they were hitting their desired cleanliness and all that. And I noticed that on all of their machines, none of them was achieving the desired cleanliness that they had pre-programmed. The cycle had terminated based on maximum time, not cleanliness, which is not desirable. Doesn't mean the boards are dirty. It just means it didn't hit a number. And I thought it was curious. My first thought when I looked at the first machine was there something wrong with this machine? But then when I looked at I think they had 8 machines. When I looked at all 8, they were all the same way. So I'm like, okay, chances are very unlikely there's something wrong with 8 machines. What could do this? Well, let me look at the quality of the DI water, since that's what we use to gauge presumed cleanliness. We look at the quality of the DI water coming off the boards. And I went over to their machine, some third-party machine that made the DI water, and I noticed that all the alarms were on. There were several alarms. They were either green or red. They were all red. And they were producing, I think, 0 megohm water. They were producing tap water. So clearly their ion exchange resin tanks had all become spent. They were dead. And there was like 6 or 8 tanks. It was a big machine. And all of them were dead. And all the alarms were indicating all the tanks were dead. So I made a comment to my customer, I said, I think your DI tanks are dead. All your boards are technically showing a fail. That doesn't mean they're dirty, but it certainly means something is amiss, and I think it's this right here. Well, the next thing you know, and when I use the word herd, I mean it quite literally. I was herded into a room, and a bunch of people in suits showed up, and they were very insistent that I state out loud that I'm not saying their boards would fail. And I said, well, I'm not saying your boards would fail. I'm not saying your boards won't fail. That's not my job. My job is to point out that our machine expects DI water quality at a certain number, and it's not getting it. So the machine can't pass the boards. He says, yeah, but you're not telling us that the boards are bad. I said, correct. And I'm not telling you that the boards are good. I'm just stating some facts. But they really wanted to hear something I couldn't say. And why are suppliers so afraid of their customers? Well, I was intimidated by them. They really wanted me to say something which wasn't accurate. And of course I didn't say it, and they were not very happy with me. It was a shoot the messenger kind of thing. But I think it's natural when someone's holding a check over your head, and they're paying for your company Christmas party, or they're paying for next week's payroll, or whatever the case may be. You certainly are walking a very fine line by delivering bad news to customers. Maybe that's why radiologists make all the money and don't have to talk to the patient. They just tell the doctor, let the doctor tell you. So
unless they don't like the results, unless, like I said earlier, they don't fit a predetermined pattern or somebody's hidden agenda, then the reckoning comes. Then somebody's on the phone yelling at you.
Yeah. And this was one of those classic cases where what I said did not meet their desired what they wanted to hear. And, they just kept wanting to, like whack-a-mole, just kind of beat me over the head. Every time I popped up with a different way to say the same thing, I was met with another sledgehammer. And what do you do? So sometimes no makes you more money than yes. So maybe we don't do business with that type of company anymore, because, we really want to partner with our customers, and we really want them to be successful with our products. And, we have no interest in faking it. It doesn't do the world any good. It doesn't do society any good. So why are suppliers so afraid of their customers? What's your take on that?
I've thought about that a lot. One of my answers is I think it's a function of how much of a share, using EMS companies as an example, how much an OEM has business concentrated in a particular EMS company. The larger the concentration, the greater the vulnerability, the less inclination on the part of the EMS people to antagonize the customer for economic reasons. EMS company A has OEM customer B, and OEM customer B represents, pick a number, 50, 60% of their business. You don't want to antagonize that customer. The problem there is they just think any piece of bad news is somehow going to be detrimental, when in fact, in my limited experience, again, I have often found that telling the truth of a situation is refreshing and enlightening, because many of these larger companies in particular seem to be used to people cowering before them, and they use that to their advantage. I mean, let's be honest, you and I have both experienced that. But on the other hand, a lot of information gets omitted or neglected or simply is swept under the rug out of this disproportionate fear that they're simply going to take their business away at the first onset of bad news. For example, about 2 weeks ago, we do another service we offer here is cross-sectioning. And we were doing a cross-section report for a customer. And it's a combination of a large group of pictures of cross-sections of the particular board. And we found several defects, and we described them for what they were. And they were not blatant defects like an open circuit or something like that, but they were cases where either there was over etching or circuitry was not up to spec. It was not geometrically as large or as correct as it was supposed to be. And we noted in our report to the customer, this is a latent failure. It's not failing now, but at some point in use under load, it is going to fail. And I sent the report off to the customer, and he emails me back the next day and says, thank you for the report, but your report has speculative language in it. Please take it out. You're speculating, you're raising probabilities that shouldn't be raised. And I wrote the guy back after thinking about it and said, these are not purely speculative statements. These are based in experience. When we see a certain defect in our experience, it has a probability of leading to this failure. You, and by extension, your customer, need to know that. I am not going to change that report. This is what you paid for from us. This is what you're going to get. I am not going to sanitize that report. So the report stands as written. And, unlike politicians, no, it was not taken out of context. What we said, we meant it yesterday, we mean it today, and we stand by it.
It's not fake news. I guess we have to ask ourselves, who do we want to deliver the bad news? The company we pay or the company that pays us? And if we receive bad news from someone we pay, we have time to correct it before the person who pays us delivers us the bad news, right?
Right.
Yeah, that makes sense.
Now you can structure the language diplomatically. I mean, you don't have to say this is the crappiest board I've ever seen in my career. You can say, we're concerned about certain things we're seeing here in Exhibit A, B, and C. See a magnified view. We see crack propagation here, which could lead to this failure there, and do it in a very professional way. And obviously, we try to do that every day. But people being people and sensitivities being what they are, sometimes they come back and say, "Can you manipulate that?" And we tend to take a dim view of those requests.
It's back to being an inconvenient truth. So my last question before we wrap up is, what are the common mistakes made when testing or when not testing? I'm sure you have seen them in your many years of experience.
Common mistakes on boards that we see to be tested?
Yeah. What either when customers ask you to test A and your experience is really they should be testing B, or they don't ask you to test something that you really think that you should be looking at. Are there, I assume that happens all the time. Is there a commonality? Is there a particular test that people ask for and you just roll your eyes and go, that's not the test. Everyone asked for it, but that's not the test. There's something better. You gave one example of redirecting the customer to a more cost-effective test. But is there a particular type of test that everyone thinks they need because whoever builds the equipment is really good at convincing people they need that test versus maybe a lesser-known test that provides more value?
One of the tests we do that I mentioned earlier is something called automatic X-ray inspection, and a very common tool used for AXI is an Agilent 5DX AXI machine. And people constantly mistake what that terminology means. They think 5DX describes a capability or even physical dimensions, 5 dimensions, right? Length, width,
sure,
depth, time, and some amorphous 5th dimension. And you would be amazed at how many people will call up and ask for variations on a theme of 5DX. I want 2DX, I want 3DX, I want 4DX, I want 5DX. One fellow even wanted 8DX last year, which we really got a chuckle out of us in the office coming up with 8 dimensions on a board.
So 5DX is a registered trademark of some company.
It's a trademark. It's nothing more than a trade name that the marketing department at HP/Agilent/Keysight came up with to market their machine. And they came up with the term 5DX rather than 4DX because they wanted to market it in Asia, and the number 4 is a bad number in Asia, and the number 5 is a lucky number in Asia. And that's the answer, full stop.
Well, that explains why someone wanted 8DX, because 8's an even better number, and 9
Precisely.
9 is good. Oh, no, is 9 good? Yeah, 8's good. 8 and 6 are good numbers. So yeah, so let's do like a 8888 DX, and our boards will never fail.
Our job as test engineers is highly technical, and a large part of my job as the president of the company is the initial engagement with the customer. And a large part of that initial engagement is simply educating the customer on what's available, what it means, cutting through the fog of terminology that has confused them, the whole 5DX, 8DX mess, explaining what each does, the relative strengths and weaknesses of each, and describing what, based on the facts they've given me, what we think is suitable for their application, and steering them in the right direction where they're spending their money wisely. And if we do that, we usually, more often than not, will have a happy customer who gives us repeat business, and hopefully will think well enough of us to recommend us to a colleague down the road when they have a similar problem.
That's excellent. And I'm going to end this with a virtual emoticon thumbs up. And I have 139 more characters left to send you a message. Thank you, Robert, for being my guest, president of Datest. And how do people get a hold of you if they want to? How do they find your company?
You can find us on the internet. Our website is www.datest.com.
And that's DATEST.com.
DATEST.com. And you'll find all our contact information there. And I appear fairly frequently on LinkedIn and in other venues. I'm very active in organizations such as SMTA. I'm currently the Silicon Valley chapter president, at least for the remainder of this year. And so I am around. And as you said at the beginning of our interview, I'm at a lot of the major functions and trade shows, and we bump into each other there.
Okay, excellent. Hey, you're a wealth of knowledge, Robert. Thank you so much for talking test and other philosophical things. I like kind of getting off the reservation a little bit and being able to talk about other interesting societal things. So we treaded some dangerous water, but we managed not to get eaten by sharks. So thank you for doing that with me. And I am going to see you in December. I think I'm speaking to your chapter sometime in December. Is that right?
Absolutely.
Well, I'll look forward to it as usual. And thanks again for being my guest.
My pleasure.
Well, that's another episode. Thanks for listening to Reliability Matters. If you like what you hear, please be sure to give us a like. Just click the like or heart button below. If there are any reliability-based questions you'd like to have answered or specific topics discussed, let me know. I can be reached at mike@mikekonrad.com. That's Konrad with a K. Don't miss another episode. Subscribe to Reliability Matters on iTunes or follow us on Spotify. You can also listen to us on iTunes, Spotify, aqueoustech.com, PCBchat.com, Spreaker.com, or our newest affiliate, Ascendo Reliability, on reliability.fm, a site dedicated to all things reliability. Once again, thanks for listening. We'll be back soon with another episode of Reliability Matters. In the meantime, keep doing it right.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.